let's take a look at this example. So at the instant a traffic light turns green, a car has been waiting at an intersection, starts ahead with a constant acceleration. Constant acceleration means I can list my variables and pick one of those equations from the sideboard there. At the same instant, a truck traveling with a constant speed of 20 meters per second overtakes and passes the car. How far beyond the starting point does the car overtake the truck? When are they at the same location? Okay, so I know that they both start at the stoplight, which I'm going to call 0 meters. And sometime later, they're going to be at the same final position. Now, because they also start at the same time, these t's here will also be the same. We need to figure out what variables are in common so that we can set up our system of equations. We'll have one equation for the truck, one equation for the car. Now, they do tell me that the truck has a constant velocity, meaning the acceleration is 0, and they're moving at 20 meters per second. They timed that pretty well for how fast they were going. The car starts at rest and has an acceleration of 3.2 meters per second squared. Now we want to generate the equations or pick the equations to create for our car and our truck. Now, whenever the acceleration is 0, we're always going to be using equation number 3. So we'll be using x is equal to x naught plus v naught t plus 1/2 at squared. So this acceleration goes to 0, or brings that term to 0. And so I'm left with x is equal to 20t. Now I'm going to put in the 20 here because I don't want to get these two v naughts confused. But these x's are the same, so I'm just going to call it x. I don't have to say like x truck or anything like that. Over here, I don't know the final velocity, so I'm going to pick an equation that doesn't have final velocity. Turns out it's also equation number 3, so I have x equals x naught plus v naught t plus 1/2 at squared. Starts out at rest and has an initial position of 0. And so now I have x is equal to 1/2 times 3.2 t squared. Again, I want to put in that a so I don't get my a's confused. All right. At this point, I have two equations, two unknowns. I'm just going to go ahead and set them equal to each other. So I have 1.6 t squared equals 20t. Since they were both equal to x, I can set them equal to each other. And I'm going to solve for the time. Now, you'll notice there's a time on both sides. What I can do is I can cross out one of those times. The other way is to move that 20t over to the other side and factor out a t. And so I have 1.6t minus 20 all times t equals 0. And so I say, oh, one of the solutions here is t is equal to 0 seconds is one of my solutions. The other solution is when this condition is met, so t is equal to 20 divided by 1.6. 20 divided by 1.6 comes out to 12.5 seconds. That's the one I'm concerned about. Is this 12.5. I know they start at the same time. I'm trying to figure out when does the car overtake the truck. So this is the time at which it occurs. To find the position, I'm just going to take that 12.5 and I can plug it into either equation here to go ahead and solve for that position. I'm going to plug it into that one. So if I do x evaluated from 20 times 12.5, I end up with the position that they're at when it overtakes of being 250 meters. My handwriting's a little messy there, so hopefully it's 250. 250 meters is the location that that car now catches up to. Now that car is still accelerating, so they are going to go ahead and pass that truck. Part B says, how fast is the car traveling when it overtakes the truck? So now I want to know the velocity of the car at 12.5 seconds. So I can go, oh, okay. So to find that velocity, v is equal to v naught plus at. So I can plug in my 3.2 times my 12.5 to find the velocity of that car. This is slightly comical. They're going 40 meters per second and still speeding up. So they're approaching 100 miles an hour and are really just loving the stop sign, gun it afterwards. So they'll probably have to start slowing down at some point here though. So that's B. C wants me to go ahead and sketch an XT graph of the motion of both vehicles. So a position versus time graph. Now, when we get to the AP test, one thing we're going to want to make sure of when we sketch, that word sketch is a pretty loaded term. It means I need to put things like intercepts. I need to put points that I know. I need to put asymptotes. I need to label a lot of stuff. So for me, I know that they are going to meet at 250 meters out at 12.5 seconds. I know that the truck is going to have a constant speed of 20 meters per second. So that's going to be the slope for our truck. So this will be the truck. And I know the car starts out with a velocity of 0, so it should have a slope of 0 initially, and it's going to speed up as it goes through that point there. And so that would be the car. So I just need to make sure that that point is well defined on my sketch, that it's crossing at that point. Okay. Part D says sketch a velocity versus time graph for both vehicles. Okay. So I'm going to be sketching a velocity versus time graph. All right. So velocity versus time, they're both moving in the positive direction, so I only need that first quadrant there. At 12.5 seconds is when they are going to have traveled the same distance, meaning the area under those two curves is going to be the same. The truck moving at 20 meters per second. The car is going to be ending at 40 meters per second. And so let's try some colors this time. So the truck I'm going to make green. So this is the truck. And so its area under that curve, 250. The car, I'll make it red. The car starts out at rest and ends at 40. So it's going to look something like this. And so we can see that that area, like if I took this little triangle and dropped it in there, it should add up to that same 250. So maybe I'll even like put my little dash line there, label this car. We're good to go. There's your example.